Welcome back. We are in lesson 113, and first we need to review and refresh our memories on the rules for exponents. So we remember the basic or the first rule that we learned, which was that when we multiply the same base with a exponent, we can add the exponents together. So that would be x to the 9, right? We also learned that when we have some division going on here, and we have exponents, that we can factor out or subtract the smaller exponent from the larger. And then that gives us either a fraction or it gives us a whole number. So we know that if we have 7 over 2, what we're actually seeing is x squared. We can break it up and then factor that out. Or it's also the same thing as saying x to the 7th. When you bring this up, it becomes a negative number, and it becomes x to the 5 as well. So you would have the same answer regardless of which way you thought about it. It's all about how thinking about it works for you. But this process of bringing it to the top and turning it into a negative integer is just simply an easier way to illustrate the process of canceling from one side to the other. Okay? The other and final exponent rule we're going to talk about is the product rule. And that's when we have a base and an exponent raised to an additional exponent power. And all we do here is we simply multiply. 7 times 2 would be 14. So this would be x to the 14th power. Easy peasy. Those are our 3 rules that we use for exponents. And those are also the only 3 rules for exponents. Those are the only 3 rules that are used for logarithms as well. So let's talk about logarithms now and what makes them somewhat difficult. So what makes logarithms difficult for some people is the use of the word logarithm. But I'm going to give you an illustration here to help you with that. So if I have 10 squared, we know that equals 100. We know that 10 is our base. That is the number. The base is the number that is going to be multiplied, right? And we know that 2 is our exponent. The exponent is the logarithm. It's the same thing. Now, 100 is called the solution to our little math problem here, but the solution has another name. It is the anti-logarithm. So that little illustration there should help you a lot with understanding what logarithms actually are. The problem is that we write them and say them completely different from what we're already used to. So what we would write for this would be the log of 10 here. And the way we would say that is the logarithm of 100, so the logarithm of 100 to the base 10. So the logarithm of 100 to the base 10 is 2. So it's logarithm of 100 to the base 10 is 2. It's kind of a zigzag if you think about it. So you read the ones on the same level first, and then you remind us what the base is, and then you give us the result. But that's how you write it, and that's how you say it. Okay, so you're going to want to put this in your notes. Now, the base of a logarithm cannot be the number 1, because 1 to any power is still 1, right? It doesn't matter. 1 squared is 1. 1 to the 4,327 is 1. It doesn't matter. 1 is 1 is 1, so we can't use 1 as the base because it doesn't actually solve anything. It doesn't give us a solution. There's no point in it. The number would still be the same. Also, the base of a logarithm cannot be 0 because 0 to a positive number A positive power is 0, so a logarithm cannot equal 1, cannot equal 0. 0 to the 0 power is undefined, and 0 to a negative power is also undefined. So the base of a logarithm can be any positive number except for 1. Bases other than 10 and e, and I'm going to get into e in just a moment, are rarely encountered in algebra, so we will concentrate on the bases 10 and e. So let's use the calculator. I hope you've finished writing these notes down. I'm going to clear the page. Let's find the logarithm for 105 to the base 10. And actually, let's go ahead and write this down. So the log of 105 to the base 10 is, that's how you'd write that. And we'd pull up our calculator and we would put that in this way. You'd say 105, and then you see this little log 10 button. You might just have log, or you might have log 10, but you click that and it gives you the answer. How easy is that? So we would type our answer here, 2.021189299. And the reason, I'll show you why I stopped at 9. Typically, when you come up to a 0, you can stop right between the last number and the 0. That's a good stopping point. Okay. So technically, 105 is about equal to, and we say approximately equal to because we rounded this number. We stopped it at this last 9. Is approximately equal to 10 to this power right here. So you can see why you wouldn't want to write that as an exponent. You can see why you would want to write it like this instead to find that exponent. It might be a little bit easier. But this is the logarithm of 105 to the base 10 is 2.021189,299. All right, so that's how we would solve that. Since the exponent is a logarithm, we can also give it that scenario. When the abbreviation log is used, so if this is written, this is the other way it can be written. You could say the log of 105 is 2.021189,299. It's understood that this is 10. So if you don't write it, we default. Kind of like when you have a square root, it's defaulted to 2. We don't have to actually write the 2 in there. This is the same thing. When you just write log, it defaults to 10. You don't have to actually write the 10 in there. Okay? So the default log base is 10. And that's why you have a log 10 on your calculator. So let's clear the page and talk about something else for just a minute. The number e, so yes, I said that right. The number e is known as the natural logarithm, and it's abbreviated IN. It's an irrational number, and that's very important in calculus and other advanced math courses. The decimal approximation of e to 10 decimal places is this. I'll just rewrite it below. E is approximately equal to 2.7182885. Sorry. It's very long. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that is e to the approximate. Just like we have pi is 3.14, e is 2.7182818,285. So you're going to want to memorize that or write this on the back of your notebook for a reference. This is the value of e. If a number is entered on a calculator and the ln key is pressed, the calculator will give the proper exponent such that e to the power equals the number. To find the base e logarithm, this is what we do. We type in 105 and we press the ln key, or the in key, sorry, and we get 4.653960350, and we stop at the second zero here. 1, 2, 3, 4, 5, 6, 7, 8, just the 8th decimal place here. So that would be the way we would write that is we would say the log of e, or the logarithm of 105, the base e, is approximately equal to 4.65396035. That means that since the exponent is a logarithm, we can also write like this. 105 is approximately equal to e to the 4.653960335. Instead of writing log e, we usually write the abbreviation in here. So we usually just write in instead of log e, so there's no confusion. So let's talk about anti-logarithms for a moment. An anti-logarithm is the number we get if we raise the base to the logarithm or the power. It's the solution. If we are asked to find the base 10 anti-log of 4.316, right? So the base 10 anti-log of 4.316, so that's our anti-log. We remember that the number is the anti-log and that this must be the exponent. So we want to evaluate that. So what we do is we pull up our calculator to get the answer, and we would type in 4.316, and we would get the inverse operation to the log, and I'm looking for the inverse operation to log. I'm not seeing it. Hold on just a moment. Okay, so the inverse operation to the log is right above it here. It's the 10x. So I would type in 4.316 and I would click the 10x, and this would be the answer that we are looking for, 20,701.41. I'm just going to stop right there for now. So that would equal 20,701.41. That means that 10 to the 4.316 power is equal to 20,701.14. We could also have found the inverse logarithm of 4.316 by using the y to the x key to raise 10 to the 4.316 power. So that means instead of using the inverse log, we could just use this power here. We could say 10, and then we click the XY key, and then we put in 4.316, and we hit equal, and it's the same answer. Okay? So we could do it either way. We could use the inverse log, or we could use the XY key to put in the base of 10, and then the exponent, and then hit our equal sign. All right. So let's do a practice problem here. Let me clear this, and let me clear this. If it'll let me, there it goes. All right, so we are going to use our calculator to get a value for e. So we know that e raised to the 1 power equals e, right? So we are going to pull up our calculator. Let me write this down. 1.1 or 113.1 All right, so let me solve this for us. We're going to use our calculator to get a value for e. We're going to press 1, and we're going to press the inverse operation to in, that's ex. And it gives us the value for e, and that's pretty awesome. All right, let me clear this. Let me put the next problem up here for us. So first, we are going to use the log key to find the proper exponent to write each number as a power of 10. So here's our calculator. Let me clear this off. So first, we are going to type in the number 47832 to the log 10. And we're going to round this to 2 decimal places. We'll say 4.68 just to make it easier. So that would be 4.68. Actually, let's do 10. 4.68. All right, and then we'll do 10. Let's do this one. So 59463. And that's going to be 10 to the 4.77. So 4.77. We're just going to use 2 decimal places. And then this one is going to be 10. And because it's a decimal, it's a negative log. Just like any other exponent, those rules apply. When it's a decimal, think scientific notation. When you have a decimal, that becomes a negative exponent, right? So let's do this. We're going to type in our number, 0.000817, and get our log as a negative 3.087. We are going to round that up to negative 3.09. So that'd be negative 3.09. We could use the y or the xy key to evaluate 10 to this power, but we'll use the inverse log key to find the anti-logarithm. So first we're going to solve this. Let me move it over so we can solve it and have a little bit of room to do that. So we know when we multiply the same bases together that we add these two together, right? So what we're going to have on the top is 10, and we're going to have 4.68 plus 4.77, and that's going to equal 10 to the, actually, I take that back. We're going to take this and bring it up to the top. So that's going to make this a positive because we're taking that negative sign or bringing it up here. We're going to make it a positive 3.09. So now we add all of these together. And so we are going to have 4.68 plus 4.77 plus 3.09 equals 10 to the 12.54. Now what we're going to do is we're going to use the inverse log keys to find the anti-rhythm. So we're going to, or the anti-logarithm. So we're going to just use this key here, 10, 12.54, and that's a really big number. And it's, what we're going to do is we are going to write this in scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places is where we would have to move the decimal, and we're going to round that to a 7 here. So that would be 3.47 times 10 to the 12. That would be our answer. All right, let's do one more. Actually, let's do a few more just to get this in our head. So let's clear this. It's thinking. Here we go. Let's clear this. Let's do 113.3. me write it up here for us. All right, so the first step, we're going to find the logarithm to put it into base 10. So let's use base E logarithms to simplify. So we'll use the LN key on the calculator. So 4, 7, 8, 3, 2, and we'll use this IN key. That's going to be 10.78. We'll round that to 2 decimal places. So this is e to the 10.78. And this will be e. We'll find that value in just a minute. So we're going to do 59463 to the e, so 10.99. And we're going to put that over the top of, get my calculator back up here, 0.000817 to the e. It's going to be negative 7.11, because it's a 9, we might as well round it up. So it's e to a negative 7.11. All right, so now all we're going to do is the same thing we did before. We're going to say e, and then we're going to add all our exponents together. 10.78 plus 10.99, and we bring this to the top, it becomes positive, plus 7.11 equals e to, let's see what we got, 10.78 plus 10.99 plus 7.11, 28.88. So e to the 28.88. So we'll find the anti-logarithm of 28.88 by using the inverse key for IN. So all we have to do is take this number, and now we just press this key here, the e to the x. And then we do the same thing we did before. We count all the way till we have ones place only. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places again. So that's going to be 3.49 to the 12. So 3.49 times 10 to the 12 is how we would write that in scientific notation. All right, let's do one more. Let's do 113.4. And this one says that if the negative 0.0325 equals log of e, y, find y. So we don't know what the log is for that number, right? This is the exponent. We don't know what the anti-logarithm is. So in a logarithm problem, there's a base and 2 other numbers. The base is the problem, and this problem is e. The problem states that this is the logarithm. So y must be the anti-logarithm. So what we're going to do is we're going to open our calculator up. This is basically all just a bunch of calculator work. And it's really about knowing what to enter in your calculator to solve it. So we are going to enter 0.0325. We're going to make that negative because it's a negative number here. So you just click the positive negative sign on your scientific calculator. And then we're going to hit the inverse log key, which is this EX right there. And we get 0.968. So that's our answer, 0.968. So the log E of 0.968 is equal to negative 0.0325. And that is how we would write that. or actually I take that back. We would write it like this. E to the 0.968. Oh, I had it right the first time. Log E of 0.968 is equal to this, but we could also write it as E to the negative 0.0325 is equal to 0.968. All right, so those are saying the same things. All right, we have one more. 113.5. So if y is equal to 4302, find first, or A, the log of y, and B, the inverse of y, the inverse log of y. So for solution A, we want to find the log of y. All we have to do is, first let's set it up with our answer. So the log of 10,4302 is equal to, so now we get this, we clear this off, we write 4302, we press our log 10 key, and it's 3.63. Right? That could also be written as 10, 3.63 is equal to 4302. Either one of those is the same thing. And now we're going to find, this was A. Now we're going to find B, which is the inverse of y. So we're going to clear our calculator. We're going to type in our number again, 4302. And we're just going to type the inverse log, which is here. I'm sorry, I hit the wrong one. We hit the E button, not the inverse log. And we get 8.3, we'll round that up to 8.37. So 8.37, I don't want to forget that. The log E of 4302 is 8.37. You could also say E to the 8.37 is equal to 4302. All right. And that's all we have for lesson 113. I'll see you in lesson 114.